Today we're going to talk about street design. Well, street design consists of whether it's be cars, buses, pedestrians, or bicycles. When we first talk about street design, you're talking about the American Association State Highway Transportation, AASHTO. They're the ones that are going to designate what a design looks like. In addition to, you have the Institution of Transportation Engineers. Those are the ones that have done traffic studies to tell you how wide your roads need to be or what typical design they need to be. In addition, AASHTO developed a manual called the Policy on Geometric Design of Highways and Streets. These are usually the basis of design for our roadways, whether they're rural, urban, I-4, turnpikes, anything of that, collectors or arterial streets. Now, when we're talking about streets, we're talking about, if you take a look at this exhibit over here, arterial streets are your main roads. They're the ones that most of the traffic is on, like a state road 500, which is 192 in Kissimmee. You have commercial roads where you'll have industrial parks or larger trucks running. Your local roads are going to be where your subdivision streets are. And then you have collector streets. Those are your main boulevards basically through your subdivisions. And then you have public areas. Now take a look at this and you can see all the different types of roads. We have the main I-4, the 408, we have individual little street roads, and then we have collector roads that go for our subdivisions. So you can get a different idea of what the design of the street needs to be depending on what purpose it is. So even from Google Earth you can tell that the roads that have more traffic are wider than the roads that have less traffic. So you can also see from this picture we have different designs. We have I-4 here and we have a ramp going on. We'll talk about super elevation when we talk about ramps. We also have roads that are a bit wider than our local street roads. We also have difference in curves of roads based on whether they're interior to subdivisions or not. Also, you have to think about if this is a commercial area or industrial area, what type of traffic is on there, what type of vehicles are being driven on that road. So if it's commercial, industrial, you're thinking larger trucks, heavier trucks. So their roadway design, not just the layout of the road, but the actual asphalt base, subgrade, what the material of the road's being made out of. Your subdivision roads are going to be something that's going to be a little bit lighter and even narrower than roads that are in a commercial district. Now, some of the design considerations when we design roads, we've got traffic volume. Is it I-4 or is it a local subdivision? Circulation and access. How are we moving these people around? Is it going to be congested or not? The driver's characteristics, the different types of how they accelerate, the studies that have been done on the minimum standards in driver's behavior. You always see that when you're looking on the on-ramps of Turnpike or I-4 that they're always cautioning you to go 35 miles per hour. But we know nobody really goes 35 miles per hour on that ramp. They go 50, 60, whatever. But the design of the road is determined based on the driver's behavior and not what we want them to do. You also have vehicle characteristics. Is it a semi? Is it a dually truck? Or is it, a Mini Cooper? Those are the different characteristics that a car has and how that affects the street's functionality and whether you're designing it for commercial, industrial, or a subdivision. Okay? So when we talk about volume, there's actually been traffic studies done. So if we're having a major highway, we know that we have a multitude of cars going on it. So the road that's designed for those cars and the lane structure and the width of lane, the faster the cars go, the wider the lane is. The slower the cars go, the narrower it is. Is it going to be something that's in a rural area that's going to carry our semis and trailers carrying goods across the states? They actually have different roads. You can actually see the grass and the guardrail and the median in the grass. You also have downtown areas possibly where you have bicycles and you have to put in 5-foot bike lanes. How is that going to affect the whole design of our streets? And now they're putting bike lanes in your subdivisions on at least your main collector roads. When we talk about super elevation, we're talking about when we're driving up a ramp, you can actually see that the road is tilted. as you go into a curve, the road tilts, and as soon as it goes flat and straight again, the road actually reverses and flattens back out into a cross section of going cross slopes, going different directions. So you have centrifugal force that goes through, that's holding your car on here as you're driving along at higher speeds. You also have horizontal curves that may or may not have a super elevation on it, but typically they do if they're curved steep enough. So you have to take into consideration what a horizontal curve design may look like. Horizontal curves, you have different aspects of the horizontal curve. You could have just the regular circular curve here, or you could have what's in this picture here is a reverse curve, okay? Or you could have compound curves where the curve goes into multiple. Over here is a compound curve, has two different radiuses, and then you have the spiral curve. All right. Now, as I go through this video lecture, you can pause the video and look at what's written in text and get more information on it besides what I'm speaking about. But I'll also provide the PowerPoints. You also have vertical curves. So vertical curves go up and down with the street. So we have to anticipate if we have a low-lying area, we know water is going to be flowing across that low-lying area possibly. We also have to take into account when we're driving through these roads, how are we going to be able to see whether it's a passing zone or a no passing zone. So when we're designing roads, it depends on what we're designing the road for. So the vertical alignment, we have a crest and we have a sag. So as we go over, our line of sight is different, and as we go downhill, our line of sight, especially when it's dark and you have possible animals crossing the street, we have to take into account. There's mathematical computations, and if you have or haven't taken the highway drafting and route design class, we go over these calculations both for horizontal curves and vertical curves. Right now in this class, we're just going to talk about the different types of curves. So we also have curves that are on crests, and we have curves that are actually going uphill and curves that are actually going downhill. We have a typical sag and the same going down, okay? So the curves are based on our slope going in, hitting a tangential point, and then our slopes going out, okay? We also have to worry about obstructions. Obstructions meaning how close are the power poles to the road. It could be a safety hazard. There's typically a clear zone that the rules require you to design by, but when you're in the urban areas and in the rural areas, you may not always follow those because you can see how close this tree is to the edge of that road. So we have different styles of our subdivision design. In here you can see the inlets of the roadway. That tells me that's going to be a low point and water is going to drain to the air. The difference between this design and this design, you can see the curb and gutter. This has a cross slope center lane, cross slopes down and drains to this inlet. It drains downhill and goes to this inlet. The same with here. We typically have a crowned section, meaning the center line of the road is a peak and goes downhill. But notice that we have no curb and gutter. That means all the water goes into the grassed area and drains along the grass. And you can see that the road dips, or the driveway dips a little bit, almost along with the sidewalk. Now, when you're looking at the designs of roadways, you also take into account how the cross section of the road looks. You also have street designs for within your subdivision. You have the cul-de-sac, an offset cul-de-sac, a looped road, and a T-type. What those actually look like in real life, here's the loop design, here's your different cul-de-sacs. Now, you also have the circle in the middle, okay? When we're designing for our streets, we also have to take into consideration the people on the streets besides the cars, the pedestrian, the bicyclist. We have to take into account the sight distance. That means when we come up to a stop sign, we look left, we look right. Can we see by pulling out the sight distance? So in this picture, you have a crosswalk, you have a bike lane, and all the striping that goes with the street design. So when you're talking about pedestrian and bike, you might have a very large pathway that people walk on, and then you have all your sidewalks. And here, that picture again where you have the bicyclist on the road, you can see that there's white lanes or white stripes telling you that this is a bike lane, that drivers aren't supposed to be driving in it. When you're talking about signage and sight distance, look at all the striping that's on this road. You have a crosswalk, you have where your stop bar is, your turn lanes. Now, when you're talking about sight distance, you pause here and you turn, you have to be able to see from this direction. We have to take into account, even here, you can see that little bike lane being shown on this set. When we're designing, we have to think about the traffic control also. You have, is it going to be delineated by a stop sign, or is it going to be delineated by a traffic light? You also have traffic signage that looks like this to tell you that you have a sharp turn, you have a possible overturning truck, you have a speed limit, you have exit signs. Okay, here's that same picture but a little bit clearer. You also have your turn lanes, you also have dictating curves so people can stay in their lanes. We have to design this and think about this when we're designing our roads. These arcs are specific to a certain radius because we have to get semis to go through here and we don't want them to run into somebody else's lane. We're going to stop here. We're going to talk about cross-sectional elements of our streets.